Hi, this is Irv Shapiro with the Dr. Vax channel, and today we're going to talk about how to go from prints that look like this, filled with stringing, to prints that look like this, that are almost perfect. And along the way, we're going to look at a range of slicer parameters. So it's really important that you watch this whole video to get the most value. And in addition, we're going to talk about print geometry. What are the finest features you can accurately print on a 3D printer, and how does that impact stringing? So stay tuned and let's learn something together. As you can see from the number of models here, and there were many more that I printed, fine-tuning a profile is a lot of work. But in fact, to get a good profile that does very little stringing is not much work at all anymore. This is the classical string test, which has two towers that are about 3 millimeters in diameter, and it prints perfectly on my printer using a default Cura profile. Now, what printer did I use? Well, it started as an Ender 5 earlier in its life, and as you can see in this picture here, it's now changed a lot. So I added an all-metal hot end, I added Capricorn Bowden tubes, I added a new control board. In essence, it's a brand new printer. It even has a new extruder that you'll see pictures of later. So it has to be tuned like a new printer. One of the things that's so very important is when you make a change, you probably have to retune your profile. A change could be a different brand of filament. In some cases, people claim that the characteristics of different colors of filament work differently. Change is clearly a new extruder, a new hot end, a new control board, a new type of Bowden tube. These are all changes that impact your printer. So while my printer started as a Creality Ender 5, and I love that the Creality Ender line of printers is so hackable, today it's really a Dr. Vax printer. One of the challenges I had with this printer is that when printing very narrow towers at the top of prints, there was a lot of stringing. Now, this printer has a Micro Swiss hot end. It's an all-metal hot end. And all-metal hot ends give you the advantage of printing at much higher temperatures between the Capricorn Bowden tubing and the all-metal hot end. Instead of printing up to about 230, 250, I can print up to about 280 plus degrees centigrade on this printer, and I can do it safely. But the standard profiles create a lot of stringing. So let's dig in and learn about this. To begin with, we have to understand what is stringing, what causes stringing. So let's look at a picture together. This is a picture of the G-code preview mode or the simulation mode on Simplify 3D. Now you'll see all of the red lines. Those are travel moves. A travel mode is when your printer, after it's done extruding filament, needs to go somewhere else to extrude more filament. But in between those 2 points, let's say when it's printing this tower and then it moves to print this tower, it doesn't want to extrude filament. That's called a travel mode. Now, if there's a little bit of filament leaking out of your nozzle, it's going to create a string. If there's a lot of filament leaking out of your nozzle, you'll have something that looks like this. So each one of these red lines on this picture you're looking at has the potential for stringing. Now, let's look at how these towers are going to be printed live in a live preview. Now you'll notice here that it's printing the inside and then the outside of each of these towers. The order that you print walls or particular objects, the outside of objects, is important and will impact stringing. Let's think about it. You're printing the inside, then the outside, and then you're moving. If instead you printed the outside and then the inside, when you first go to move, you're in essence dragging the nozzle over that outside wall. That's actually called a wipe, and that would reduce stringing. So one of the things we could see from watching this video was perhaps we should change the order that we print the walls. Now the two prints you're going to see now were in fact printed on different printers. So this was a default profile on my Ultimate 2, my Monoprice Ultimate 2. This was a default profile on my Ender 5. Now the Ender 5 profile I'm using came from Cura, and the new profiles in Cura are generally quite good because, as I showed you earlier, you can get really nice prints with no stringing if you don't have very fine features. But if you look at the top of this print, it's ugly, but this shows you what's possible. Now there are other differences here. This is a Bowden tube setup. This is a direct extruder. By adding an all-metal hot end, I increased the amount of stringing on this printer in exchange for higher temperatures. So our challenge today is to go from this to this. Now, the most important parameter that you may have to tune, assuming you're using default profiles, which as I said today are very good, is temperature. And a wonderful way, and I'll link to this in the description, is to print a temperature tower. And we'll see a picture on the screen of this close up. And what you basically do is you go into your slicer, I'm using Cura for all the examples here, and you tell it at different layers to set different temperatures. And then you look at the amount of stringing. You can see the stringing better on the back of this. And then you pick a temperature where there's the minimal amount of stringing. What I found is I've been printing too hot. I've been printing almost all PLA at 205 degrees centigrade because that's what worked best for me a year and a half, almost 2 years ago on a Prusa i3 MK3. I think it was about a year and a half ago. And I found that that's the wrong temperature. By looking at this tower, I see that the stringing really stopped at about 195 degrees. So the tests we're doing today are at about 185 to 190 degrees in order to reduce stringing. But even at that temperature, I still saw a lot of stringing. Now, before we look at the other parameters in Cura specifically, but the concepts apply to all slicers that impact stringing, we need to understand the concept of a 3D printer and extruding filament and what happens when you extrude filament. So let's look at this picture together. There are really two basic types of printers, or two types of setups for extruders. In the more common setup, at least for low-end printers, and the majority of the printers I own are this type of setup, you have an extruder, which is either a set of gears or a gear and a wheel that pushes your filament through a tube. This is called a Bowden tube. Bowden tubes come in different quality. The standard Bowden tubes provided with many printers are good, but not great. What makes it great? Well, the accuracy of the channel or hole in the Bowden tube and how slippery the material is. This is Capricorn tubing. It's not expensive. It's probably one of the least expensive, easy upgrades to every Bowden style printer you own. This is very slippery and very precisely manufactured. Now the extruder, once again on the picture, pushes the filament through the Bowden tube to the hot end. On the right side, we'll see a direct drive extruder. I own 3 direct drive printers. That's my Prusa i3 MK3 is direct drive, my Monoprice Ultimate 2 is direct drive, and my Quiddy printer is a direct drive. And in general, direct drive printers have the advantage that there's less play in the filament because it's going directly from the extruder to the hot end. It doesn't need to travel over something that can wiggle and vibrate and may have clearances that are a bit too wide in the tubing. That means the printer can more precisely control the extrusion of filament. The disadvantage of a direct drive extruder printer is you have all of this weight moving around, which can increase vibration if the printer is not robust enough. Okay, now let's look at some of the parameters that impact how the extruder interacts with your hot end and how it controls the flow of filament from your nozzle so you get just the right amount of filament out to have a proper print, but not too much where it starts dripping or oozing out of the nozzle, which causes stringing. The most common set of parameters that impact stringing are retraction. And in most current slicers, that assumes that you've loaded the most current version. So if you're on a 2-year-old version of Cura, you're not going to have built-in profiles that are excellent. If you're on 4.6.1, the built-in Ender profiles, as an example, the Creality profiles, are quite good and will give you very acceptable prints, except in extreme circumstances. So we're tuning for extreme circumstances. So the first thing you have to look at is retraction. That includes the amount of filament to retract. Now, when you have this floppy tubing, you have to extract more filament because there's actually a little bit of give in the tubing. So you might be extracting, you might be pulling back 3, 4, 5, 6, or 7 millimeters of filament. Now, there's a misconception. When you're pulling back on the filament, you're not pulling any filament out of the nozzle. The filament in the nozzle is melted. It's soft already. You're not going to be able to pull it back. What you're doing is reducing the pressure that you have on that nozzle. By pulling back the filament, you're reducing pressure. That will reduce oozing and leakage from your nozzle. The other parameters you change are the speed you pull it back at and the speed and amount that you push forward when you're going to print again. Now, why does the prime parameter, or the amount you're pushing forward, have an impact on stringing? Because what you want is you want to keep just the right amount of soft melted filament or semi-melted filament in that nozzle so that the filament in the nozzle will adhere to the filament that's coming out of the nozzle, and you'll have a good connection there. Because if you pull too much back or you pull back too fast, then you have soft filament in the nozzle. There's nothing holding it at all. Maybe you've snapped off, in essence, the filament that was connected to it. So you want to get the flow optimized by optimizing the amount of retraction, the speed, the amount of priming, and the speed of priming. Now, in a typical direct drive, direct extruder model printer, you'll often pull back 1 to 2 millimeters of filament. In a Bowden tube printer, you'll often pull back 3 to 7 millimeters of filament. The next thing in Cura that will impact stringing is combing. When you're printing, you stop, you're going to make a move. If the area you're printing over is going to see another layer on top, don't bother retracting, because we don't care about strings that are inside. Now, in fact, if you have on your final layer, on the top of your print, if you're printing relatively thin walls, you'll actually see those strings through the walls. So you have the option to turn combing off, to comb only in the fill area, or to not comb on the outside of your model. I recommend the selection of not combing on the outside. In earlier versions of Cura, this was not the default. It is today. Once again, slicers are getting better and better. Next, we have an option called coasting. What that basically says is, instead of pushing filament out for the whole print length, when you get towards the end of the area you're printing, stop pushing, because there'll already be enough filament there to continue out. That's called coasting. Because I'm having difficulty with this model, and I noticed that on the bottom it's fine, on the top as the towers get narrower, it starts stringing, I wanted to see what the size was that causes stringing. I created a model where we have 3mm, 2mm, and 1mm towers. And this is going to be printed in this direction. So you can see anytime it goes from a 1mm tower to another area, there's stringing. When the other area is close, the strings end up connecting. When they're not, they end up sort of just floating around in space. So what I found is that for my Ender 5 with an all-metal hot end, a post size of less than 2mm will increase the amount of stringing in the model. So if you're creating a model, that's something to think about. You perhaps want to keep features at about 2mm or larger to reduce stringing. Now that we've covered a range of parameters, the first thing you need to tune, once again, is temperature. And that will get you to a print that looks like this. With 2 and 3mm towers, you'll have prints that have almost no stringing on them. But for many printers, if you go below 2mm, such as the top of these towers, you're going to have to do some more tuning in order to get it right. Now, part of what you're attempting to do is control the flow of material. Because in these really nice prints, this is in the Ultimate 2, it's not only a lack of stringing, and there's some very fine stringing here, but you can barely see it, and you could literally just snap it off with your fingers. The tops of the towers are very precise. These towers look really beautiful. If you look at some of these towers do not. They look like they have a serious problem. Let's look at a video of what happens in very narrow towers when your printer is not tuned properly. So we can see here we're going from the 3mm to the 2mm to the 1mm tower. And did you see that? On the 1mm tower, the tower was vibrating, it was shaking. So what that's saying to us, first of all, a 1mm feature is very thin. These ear savers that work with masks that I made for some buddies of mine who are doctors are about 1.2 millimeters. You can see they're very flexible. So if you're printing this vertically, this is going to move around even if you print it perfectly. So we need to ensure that the flow of filament to these towers is perfect. And that really takes me to the conclusion. The way I went, and this was printed with the newest profile, from these terrible prints with the original profile where the tops weren't very good, but they printed this model fine, to this one where it's pretty darn good. This is on the Ender 5. It's not quite as good as the Ultimate 2, still a little more work to do, but it's pretty darn good, was by thinking about the flow of filament. So I want to keep that all-metal hot end full of filament, but not too full. If I pull too much out, it will string more. If I don't pull enough filament back to reduce the pressure enough, it will string more. If the timing, the speed at which I push filament in and pull it back is not optimal, the hot end and the nozzle won't be properly pressurized, it will string more. So let's look at the profile I ended up with. Now I will provide this profile on drvax.forum.com. There'll be a link in the notes. And you do need to know that this will only work in 4.6 of Cura. So if you're not on the current version, importing this profile may not work, but I'll also leave you a link to these slides, and you'll see on this slide all of the parameters that were impacted. As we look at these optimal parameters, there's a bit of background that's important. Number one, I'm using Cura 4.6.1. I installed the default Ender 5 printer setup, and I started with the default Ender 5.20 PLA profile. I then edited it to make these changes. These changes are a combination of experimentation, lots of models, and things I learned from looking at the Monoprice Ultimate 2 profile that produces really very beautiful prints. Now, the Monoprice Ultimate 2 is a direct extruder printer. So the retraction settings were not applicable, but some of the other settings were interesting. The reason I believe they have an impact is there are many parameters in Cura that have a subtle effect on the printing of small items, the order of the printing of walls, the impact of very small features on your model. So I brought some of those capabilities over along with the experimental capabilities. Let's get started. Filter out tiny gaps is set to on or true. Now, when you have an internal small space in your model, perhaps the very top of one of these towers, this informs Cura that it shouldn't try to fill in that space. That reduces in less blobbing or artifacts on your print. Material flow at 95, that's 95%, and that will slightly under extrude this print. The print temperature was set via experimentation with the print tower. Optimize wall printing order equals false. This was a setting from the Ultimate 2 profile. I haven't experimented enough with this particular setting to see if it has a significant impact, but I brought it over from the Ultimate 2. The retraction amount, the retraction speed, the retraction prime speed were all settings that were developed both through experimentation and by reading lots and lots of online discussions about retraction. And as you can see, it very definitely worked because I was able to get really clean prints with these settings. Skin overlap. The very outer layer is considered skin by Cura, and the inner layers of a wall, before it hits the infill, are considered wall. The overlap between that very outer layer and the inner layer here is set at 5%. That impacts the quality of your skin. This could have an impact, once again, on the towers. Print speed of 75. The default in the profile was 80. This is a minor change. Travel speed. The idea here is to travel very quickly when you go to travel, to sort of snap off those strings so they can't form. Travel, retract before outer wall. This may be a buggy feature in Cura and may cause the printer to attempt to retract before inner walls also. And so I left this off, and with it off, the quality was quite good. Once again, more experimentation is necessary. The rest of the parameters here probably do not impact stringing. They are parameters I did bring over from the Ultimate 2, and they may impact overall print quality. So that takes us to the end of today's presentation. Folks, I hope you learned a lot. I hope you'll share this information with other people that might be interested in learning this. Subscribe to the channel, and there's a new way that you can share in the discussion with other people watching this material, and that's forum.drvax.com. It's a new discussion forum. It's based on vBulletin. It's free to use. You do have to register if you want to post. That means just providing your email address so that there's a way to potentially block people that are doing things they shouldn't be doing on the forum. And so there are a number of ways now to interact with the Dr. Vax community. Thanks for watching. Have a great day. Let's continue learning things together.